Hello everyone, welcome to VNR JYOTHI Institute of Engineering and Technology. This is Manohar Reddy, Department of Cybersecurity, Data Science and AADS. Today in this talk I am going to discuss about the CPU scheduling algorithms in operating system. So in this session we are going to discuss about what is meant by scheduling, what are the different types of scheduling algorithms that are performed in the operating system. So what is meant by scheduling? So scheduling is a process of executing the tasks one by one. So how the process will be executed and what are the different types of algorithms are useful to schedule the processes and execute the jobs. So the main overview of scheduling algorithms. The role of scheduling algorithms are to manage the process execution. So here the scheduling algorithms manage the process execution in operating system. It ensures that efficient CPU utilization. So the process is requiring for utilizing the memory. So the memory comes from memory management, which is efficiently used for the CPU utilization process. And it is also useful to optimal responsible time for the different types of applications under user demands. So user always trying to open a particular process or execution of application. So whenever it is loaded to the application, automatically it allocates the CPU, it allocates the memory for the process. So because of that, the second feature is what? Optimizing CPU utilization. So the effective scheduling algorithms can increase the CPU utilization process by 70, 80, 90, up to 90%. So significantly it improves the system performance and user experience also. And algorithm suitability. So whenever you open the process, whenever you execute the applications, which type of algorithm is suitable for efficient CPU utilization process? So there are certain types of algorithms are there. So in this case, first one, the FCFS, first come, first serve scheduling algorithm, and the second one, shortest job first scheduling algorithm, and third one, priority scheduling algorithm, and the fourth one, round robin scheduling algorithm. These all the algorithms are divided into basic two categories. One is preemptive scheduling algorithms, one is preemptive scheduling algorithms, and the second one is non-preemptive scheduling algorithms. So what is meant by preemptive and non-preemptive in nature? So preemptive is nothing but whenever the process ready for the CPU utilization, process is ready for the CPU utilization, at this moment the process utilizes the CPU and again it leaves the CPU. It leaves the CPU for the next process. It leaves the CPU for the next process. So leave the CPU, use the CPU and again leave the CPU. So this concept comes under the preemptive process. And the second one is non-preemptive process. Non-preemptive process, the no process is allowed till the completion of the process execution of the burst time. So no other process is ready, no other process is not allowed to complete the process burst time. So here the preemptive process is example the round robin algorithm, and for the non-preemptive process scheduling algorithms are FCFS, SJF and priority scheduling algorithms. So out of these all algorithms we are going to discuss the first come first serve scheduling algorithm is now. So what is meant by first come first serve scheduling algorithm? It is a simple scheduling algorithms as itself, it having arrival time, it having burst times. So in these two cases, whenever we don't have any arrival time for all the process, we have the arrival time is default 0. The arrival time for all the process by default it will be the 0. So that's why we are saying the first come first serve scheduling algorithm is a simple scheduling algorithm which maintains based on the arrival time and which does not maintains based on the arrival times. So FCFS is the most straightforward scheduling algorithms where the processes are executed in exact order they arrive in the ready queue. So how they arrived into the ready queue, in which order they arrived into the ready queue will be executed based on that order. And the second one is order of execution. The processes are executed based on the arrival time. So what we mention here, the exact order they followed, the exact order they arrived to the ready queue, they will follow into the queue. So here the processes are executed based on the arrival time For instance, if a process A arrives at a time 0, at the interval of time 0, and a process B at the time 2, interval of time 2, then the arrival time 0, the process arrives, so it will be executed, it will be runs first. So that is the way of order of execution. The first come first serve follows. So here, what is the main importance of doing this algorithm process? To find out the turnaround time and the waiting time of each and every process. The main intention of the algorithms is to find the turnaround time and the waiting time. What is the importance of these two times, turnaround time and waiting time? These times will decide the efficiency of the CPU scheduling algorithms. So in this manner, in this way, we are taking this example for the FCFS order, where 3 processes are arrived at the arrival time 0, 1 millisecond and 2 milliseconds, and respective burst times also. For the process 1, burst time is 5 milliseconds. For the process 2, burst time is 3 milliseconds. And for the process 3, burst time is 4 milliseconds. So we have to draw the table like this: P1, P2, P3. And the arrival times are 0, 1, 2. And the burst times are 5, 3, 4. Right. So from this, what we have to do? The first step, we have to draw the Gantt chart. So which process arrived to the queue and which process entered into the queue first. So in this manner, we have to proceed the procedure. So in these 3 processes, the first arrival time 0 for the process P1. So we can order of execution starts with the P1. So the P1 comes here, the order of execution, and the time arrived at 0, and the burst time is 5 milliseconds. And similarly, the next process P2 comes into the order. So P2 is entered into the queue, and P2 burst time is 3 milliseconds. So that 3 milliseconds will be added to this P1 completion time, 5 milliseconds. So 5 plus 3 equals to 8 milliseconds. So 5 plus 3, 8 milliseconds we have to add here. And again, the next process P3 arrived at ready queue, so entered into the queue P3, and the burst time of P3 is 4 milliseconds. That 4 milliseconds will be added to this 8 milliseconds, so that the 12 milliseconds will be added. So from this Gantt chart, Gantt chart is the representation of all the processes which are entered into the ready queue or not. If all the processes are entered into the ready queue, then the Gantt chart will be fulfilled. If all the processes are not entered into the ready queue, may not be fulfilled the Gantt chart. So based on this Gantt chart, we can calculate the completion times for the processes P1, P2, P3. So the P1 for the P1 completion time is what? 5 milliseconds, and the P2 completion time is what? 8 milliseconds, and the P3 completion time is what? 12 milliseconds. So we know the completion times for the all processes P1, P2, P3. Now, based on these completion times, we can calculate the turnaround time for each and every process. So how we can calculate? The formula is here. The turnaround time equals to completion time minus arrival time. The turnaround time equals to completion time minus arrival time for each and every process. We can calculate turnaround time for each and every process first. Then after finding all the processes turnaround time, we can calculate average turnaround time. So here the turnaround time for process 1 equals to the completion time for process 1 is what? 5 milliseconds minus arrival time is what? 0 milliseconds. So total 5 milliseconds. For P2, the completion time for P2 is what? 8 milliseconds minus the arrival time for P2 is what? 1 milliseconds. So 7 milliseconds. For P3 completion time is what? 12 milliseconds minus, and the arrival time is what? 2 milliseconds. So total 10 milliseconds. So calculate all these 3. So 5 plus 7, 12, and 10, 22. So 22 is the total turnaround time. turnaround time for all process. Total turnaround time for all process equals to 22 milliseconds. Now we can calculate average turnaround time. Average TAT, average turnaround time equals to total turnaround time divided by total number of process. So total turnaround time is 22 milliseconds divided by, and the total number of process equals to 3. So we can calculate 7.3 milliseconds. 7.3 milliseconds. This is the average turnaround time for all the process, 7.3 milliseconds. And similarly, we have to calculate the waiting time for a process also. So waiting time for process P1, waiting time for P1 equals to, the formula is what? Turnaround time minus burst time. So turnaround time for P1 is what? 5 milliseconds minus burst time. Burst time for P1 is what? 5 milliseconds. Total 0. And for P2, turnaround time for P2 is what? 7 milliseconds. And the burst time for P2 is what? 3 milliseconds. So 4 milliseconds. And for the P3, turnaround time for P3 is what? 10 milliseconds minus, and the burst time is what? 4 milliseconds. Total 8 milliseconds. So calculate all this. 12 milliseconds. 10 minus 4, 6 milliseconds. And 6 plus 4, 10 milliseconds. So now this is the total waiting time for all process. So now what we have to calculate? We have to calculate average waiting time equals to total waiting time for all process divided by total number of process. So total waiting time for all process is what? Total waiting time is 10 milliseconds divided by total number of process 3. So 3.3 milliseconds. So this is the way we have to find the average waiting time for all the process, average turnaround time for all the process. So always you can compare the turnaround time and waiting time. Always waiting time is less than that turnaround time. So that we can say that the algorithms based on these turnaround times and waiting times, we can say that we can decide that which algorithm is best for the efficiency of the CPU utilization. And the second one is understanding shortest job first. So in this, the shortest job first, the name itself, whichever the process having the shortest job, that means the shortest burst time, is having the first priority. So here the process selection criteria, SJF selects the process with the smallest execution time. Smallest execution time is nothing but smallest burst time. Ensuring that shorter tasks are completed first, and which optimizes overall system efficiency also. So always it checks for each and every process execution time. Whichever the process having the execution time small, that will comes into the order first. And the minimizing average waiting time also. So this algorithm effectively minimizes average waiting time, leading to improved turnaround time for process and enhancing that user satisfaction and system performance. The main criteria of this shortest job first is to minimize the average waiting time, and it ensures that execution of the processes, whichever the process comes with the smallest burst time into the queue, that will be executed in the first one. So here we can see the example, the process with a small burst time execute first. So the process 1 having 6, process 2 having 2. So the table comes like this: process P1, P2, P3 and P4. There are 4 processes are available, and for these all 4 processes, the burst times are 6 milliseconds, 2 milliseconds, 8 milliseconds and 3 milliseconds. Right. So out of these all the four processes, which process having the smallest burst time, smallest execution time? So out of these all the process, P2 is having 2 milliseconds, that is the smallest execution time, smallest burst time for execution. And after that, the P4 is the smallest one. So it follows after P2. Again after that, P1 having the smallest one. After that, P3 having the smallest one. So how can we draw the Gantt chart? So the Gantt chart will be like this. The order of Gantt chart, the first executed with the P2 because it is the smallest burst time. So P2 arrived at 0 milliseconds, and if there is no arrival time for any process not given, we can assume that all the process having arrival time is 0. So P2 0 burst time is what? 2 milliseconds. And next, after P2, the smallest burst time executing P4. So P4 is entered into the queue, and the P4 burst time is 3. So 2 plus 3 will be added 5 milliseconds. After that, P4, the next smallest burst time is what? For the P1. So P1 having 6 burst time, and you can add 5 plus 6, 11 milliseconds. After that, the last one is what? P3. So P3 will be entered into the queue, and the P3 burst time is 8 milliseconds. So 11 plus 8, 19 milliseconds. So from these, we can compare, we can calculate, we can find the completion times. Completion time for P1. Completion time for P1 is what? 11 milliseconds. Similarly, completion time for P2 is what? 2 milliseconds. And completion time for P3 is what? 19 milliseconds. Completion time for P4 is what? 5 milliseconds. So these are all the completion times. Wherever the process completed its execution time, that will be comes under the completion time of each and every process. So these are all the completion times for each and every process. So we know that completion time. Now what we have to do? We have to find the turnaround time for each and every process. So turnaround time equals to, what is the formula? For the turnaround time equals to the completion time minus arrival time. So completion time minus arrival time. So now we can find for each and every process. So for P1 completion time is what? For P1 completion time is what? 11 milliseconds minus 0. That is 11 milliseconds. For P2 completion time is what? 2 milliseconds minus 0. That is 2 milliseconds. Similarly for P3 completion time is what? 19 milliseconds minus 0. That is 19 milliseconds. For P4 completion time is 5 milliseconds minus arrival time 0. So 5 milliseconds. Now calculate sum of all these. How much? 37. 37 milliseconds are the total turnaround time for all the process. Total turnaround time for all the process equals to 37 milliseconds. Now we can calculate average turnaround time. Average TAT equals to total turnaround time 37 milliseconds divided by total number of processes, 4 processes, equals to, so 37 by 4 equals to 4 9 36.25 milliseconds. So 9.25 milliseconds is the average turnaround time. Similarly, after knowing the turnaround time for each and every process, what we have to do? We have to calculate waiting time. Waiting time equals to turnaround time minus burst time. Turnaround time minus burst time. So for the waiting time of P1, equals to, so what is the value of turnaround time for P1? So 11 milliseconds. 11 minus burst time for P1, 6 milliseconds. That is 5 milliseconds. For P2, the completion time is what? 2 milliseconds. Turnaround time is what? 2 milliseconds minus the burst time is what? 2 milliseconds. So total 0 milliseconds. For P3, turnaround time is what? 19 milliseconds minus burst time is what? 8 milliseconds. So 19 minus 8, 11 milliseconds. Similarly for P4, completion turnaround time is what? 5 milliseconds minus burst time is what? 3 milliseconds. So total 2 milliseconds. Now calculate all this. Sum of all these processes waiting time is what? 18 milliseconds. So now total waiting time we know. So from this what we have to find? Average waiting time. So average waiting time equals to the total waiting time for all process divided by total number of process. That is 18 divided by 4. 18 divided by 4 is nothing but 4.5 milliseconds. 4.5 milliseconds. So this says that it minimizes the average waiting time for each and every process from comparing with the turnaround times of order of its processes. So this is the way we can execute the shortest job first algorithms. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.